How's it going, everybody out there? Welcome to Global Hack Week, Open Source Week, now in May 2025. In the chat, let me know where you're joining us from. We're just going to give folks a little bit of time to get in here. All right. Yeah, we got some folks that are actually excited to learn non SQL or no SQL DB stuff. How's it going, Bipash? Hello from Ireland, College Park, India, of course, Bangladesh. I've been good. Thanks for asking. Hello, can anyone say what's next? If you see it on the screen, we're going to be doing MongoDB 101. It's going to be an intro to MongoDB and vector search. So, all right. So, I love the energy in the chat, y'all. We got Morocco, we got Tunisia, Germany, Kenya. It's so wonderful. Really, I hope y'all have been having a good time at Global Hack Week thus far. My name is Rosendo. I'm going to be kicking things off with you today. This is going to be our welcome to MongoDB 101 and vector search session. My name is Rosendo from MLH, obviously. I'm super excited to be kicking things off here. We have some content from your favorite database's favorite database, and of course, that is MongoDB. When will Rosendo start? I am starting right now. If y'all see me on the screen, I hope that you can hear me as well. All right. So we want to help you feel more comfortable using MongoDB and vector search and truly understanding exactly what MongoDB is. And we're going to do a thorough explanation of some of its features and the capabilities possible with the platform. So before we get into all that good stuff, let's go over our agenda for today. And I do want to let y'all folks know that if you haven't checked in and registered yet, you can do so. I'm going to go ahead and pop that link up on the screen. It's going to be MLH link and everything else that you see there. I could also pop it in the chat for you. mlh.link/GHWOS525 MongoDB workshop. Make sure you get registered. Make sure you get checked in because we want to know that you were here and we want to have ways to follow up with you in case you have any additional questions. So jumping into our agenda. So we've got about an hour together and we're going to get to learn a lot. So the first thing we'll do is we'll have an introduction to MongoDB and the document model. If you've never heard of it before, that's fine. We're going to explain it in depth. Then we're going to go over a lot of important data modeling and schema design. After that, we're going to give an overview of the query language and the aggregation pipeline. These are two really distinct things and interesting features of MongoDB if you've never used it before. We're going to touch on the developer data platform. And after that, we'll do a brief overview on vector search and, of course, cap it off with Q&A. So I know we've got the Q&A all the way at the bottom, but make sure if you have any questions, I'll be coming in and checking the chat. So just make sure that you drop your questions in there and, we'll get them situated for answering at a later point in time or at a time that we pause during the presentation. So with all of that covered, why use MongoDB? I know all of you or most of you have heard of MongoDB before. They've been a huge sponsor of MLH, not only doing Global Hack Week this time around, but also at our hackathon leagues. So yeah, I'm sure that y'all have some familiarity with at least what MongoDB is, but let's take a second to really dive into why the platform is so unique, especially for hackers like you, and why you'd want to migrate from using like a traditional relational database to a document-based database. All right. So MongoDB is really an intelligent operational data platform. Because of this, it can truly transform the way you manage and interact with your data. So if you're working with a lot of data, this platform is basically a 360 solution for a lot of the things that you want to do. It's the best way to work with data. And one of the reasons why is because it has a flexible document model. So as I mentioned before, we're going to explain what a document model is. You can store your data in a way that naturally fits your application without requiring the rigid schema design that you would typically see with a traditional relational database. So this makes it so much easier and faster to develop applications. You can iterate quickly and you can like really scale up your applications quickly as well. So we're going to cover a little bit more about the schema design later. For now, we'll talk a little bit more about the platform itself. So MongoDB also enables you to intelligently put your data exactly where you want it. What that means is whether you're deploying to the cloud, whether you have an on-premises server or a server that you spun up yourself, or there's a combination of the two, the distributed architecture is really what makes MongoDB stand out. And it's a way that makes sure that your data is always available in your application. So the great part about this intelligent data placement is that it helps you to reduce the latency or the speed at which it takes the application to actually access your data. So this improves performance for everyone using your application. In other words, it just makes things go faster. Lastly, MongoDB gives you the freedom to run it anywhere you like. So they support a wide range of deployment options, from fully managed cloud services, like I mentioned before, to self-hosted services or a combination. So this increased flexibility ensures that you get to choose the best environment for whatever it is that you're building. And this means that you could easily scale up as your application grows or as your project grows. Someone asked, is that free? Yes, there is a free tier for MongoDB. Make sure you check out some of the challenges that we have, like through Global Hack Week, and you'll be able to sign up for a free MongoDB Atlas account, and you'll be able to get a couple of credits, like some credits at least, enough to get you through Global Hack Week and maybe even beyond. So make sure you check out the challenges. Moving on, one of the really great advantages of MongoDB is its ability to run in a wide variety of environments, as I mentioned before, making it super flexible. So it doesn't matter where you choose to run your application, since you're going to benefit from the same code base, the same APIs, and the same tools, giving you a consistent experience through development. Atlas has a lot of unique features, such as search and online archives. And with the MongoDB platform, you won't have to worry about any compatibility issues. There are a ton of SDKs and different ways in which you could interact with your database. So with all this in mind, let's go over some of the crucial terminology. You're going to learn what the differences are between relational and non-relational databases. All right. So as you can see here, we've got a chart. Part of it is going to be relational database management systems, and then the bottom part is going to be MongoDB. So let's go ahead and jump into it. The first thing that you're going to notice here is we have collections versus tables. So in MongoDB, you're going to use the term collection rather than table to referring to a grouping of documents. And here, as you can see, documents are rows. So any of the data that you actually input into your database. So collections can store multiple documents just like tables, and store just like relational databases store multiple rows. I already kind of got into this, but yes, documents versus rows. Instead of rows, we use the term document, and each document is a record in your collection, and it stores individual data entries. Next, we're going to look at fields versus columns. So in each document, we have fields, which can be thought of as columns in a table, and each field represents the properties of the data being stored. So an example of a field could be like a first name, another field could be last name, another field could be maybe like a user ID that you want to have. The next, we're going to talk about embedding and then linking $lookup versus parent-child tables and joins. So in relational databases, you're usually going to have a parent-child table and joins that are used to relate some of the data across multiple tables within your database. MongoDB offers a more flexible approach with embedding. So this means you can store related data within a single document. We're going to see like how some of the data is actually structured a little bit later, but MongoDB also has linking, which is storing references to related documents, and the $lookup operation, which allows for joining data from different types of collections across your database. So if you're coming from a relational background, these concepts are going to be extremely familiar to you. It's just packaged a little bit differently, and the syntax that we're using is a little bit different. But let's go ahead and take a deeper look at what the document model is, which is what I promised earlier. And you're going to see exactly how data gets set up. So as you can see here, this is the document model. You're going to see a ton of different relations in terms of graphs, key value pairs, geospatial, time series objects. These are just all different things that you can store within a document model. At its core, MongoDB's document model, it's just truly built around the most intuitive way that you can think about data. So the great part is that documents are pretty flexible while allowing any necessary data governance, or by that I mean just any sort of data compliance that you need to have in order to have an ACID database. And you could just really start with a super basic structure and evolve it as you need to. This model's versatility, it really just makes it particularly powerful for hackers, because from this diagram, you can see that whether you're storing simple key value pairs, the nested objects, graphs, or time series data, all of it really fits naturally into the documents, into the document structure. I just want to point your attention to the left side of the slide here. This is how a typical document is going to look within your database. So what does this mean for you as the hacker? This means that you can model both structured and semi-structured data without having to do any type of gymnastics to force everything into rigid tables or super complex schemas like you would have in a relational database. So take this example with the information about the matrix. As I mentioned, we have a bunch of basic metadata just saved. So you have the user ID field, the title, you got a lot of different things in there. And we also have a nested tomatoes object with more specific review and rating information from a specific website. So all this information is just nicely represented in a single coherent document, and it's human readable, and you can also query it. So basically, it's this document here, it could live like anywhere across your actual database, but right now it's just represented in a single object, which is really convenient for hackers. So let's take a look at the differences between relational structure versus document structure. So if you take away one piece of information from this workshop, I want it to be that the data will be accessed together, should be stored together. So data that you're accessing together or at the same time, it should also be stored in the same place so that it's easier to access for your database. So simply put, it should just be simplified. So in terms of where it lives, and that just improves performance, data modeling, and scalability. The idea is pretty different from relational databases because you often have data that's spread across multiple tables. So let's take a first look at the document on the screen. It's going to be the one on the right-hand side because that is in fact a document from MongoDB. The first thing you're going to notice is that it's self-describing. It contains the data and the structure, and it's pretty easy to understand the data model at a high level. You don't have to look at anything different. You don't have to look at a schema. You don't have to look at the way that the database has been designed or have any additional context other than just looking at this and understanding, oh, this is an object that has John Doe, his work, his address, and the postal code and the phone number and everything. So like that's pretty self-explanatory. So what we went over in the previous slide is that documents are inherently intuitive because they represent the way people actually think about data. When you look at this document, you see all the related data together in one place, kind of like the way you would mentally group the related data information in your mind. So let's take a look at the relational model on the left. So the data for the customer is actually split across multiple tables, and to understand exactly what you're looking at, you're gonna need some context about what this data, what the database actually contains. So this process can be kind of complex, and it's not directly intuitive without knowing which queries you're going to use to grab the data that you need, and which queries are used in the application itself. So in conclusion, by storing related data together in documents, MongoDB actually reduces the need for complex joins so you can access your data faster and more efficiently. With SQL, you have to do a bunch of joins to retrieve the data. With MongoDB, you don't have to do any joins in this particular instance. This is just data that lives all in the same place. And thus, we reduce the number of joins, which makes everything more efficient. Someone asked, is it like JSON files? Yes, it's JSON-like objects. So as you can see, they're nested within curly braces, and there are, there are different key value pairs within the objects themselves. So you can treat them very much like you would treat JSON objects. So we talked a little bit about how intuitive the data model is. So let's explore how versatile it actually is. So the documents can represent any structure of data model. So it provides incredible flexibility. So at the core, MongoDB uses JSON-like objects. I know someone just asked a question about that. And we can embed arrays, subdocuments to represent complex data. And we can also model flat data, tabular data. So for simpler data models, MongoDB supports straightforward key value pairs as well. But MongoDB can also handle really rich text data, can also represent complex relationships and hierarchies using graphs with nodes and edges. This means that MongoDB can accommodate even the most intricate data structures. So it's basically useful for anyone at any level trying to utilize a database within an application or build a database within an application. So to further boost developer productivity, you can access the documents through really just like idiomatic native language drivers. And what I mean by that is, by idiomatic is just like, it's colloquial. It's just the way that you speak. And the native language drivers are basically any of the SDKs that you would typically use. MongoDB drivers are implemented as methods or functions within the API of a specific programming language, as opposed to a completely separate text-based language like SQL. So it actually supports over 40 different languages, which is awesome for folks that, have different types of backgrounds in terms of programming. So documents are pretty natural, and in the way you model data and in the way you can query the data. All right. So I've talked about a lot about flexibility. Let me quickly explain what I mean by that. So in a traditional relational database, in order to add a new field, or if you're in the relational database mind column to an existing table, such as like, a phone number, you would actually require an alter table statement or a schema modification. And this will potentially have your application down for a little while you make those updates. With MongoDB's document model, you can actually incorporate any changes seamlessly. The application doesn't have to go down from production while you make those updates. And we have the example here on the slide. So with information, we have information about our John Doe. And let's just say we want to add his phone number or contact information. We can simply add the new field dynamically at runtime. So this means no schema migrations, you don't have any downtime with your application, and there's no complexity or extra statements. The document on the left is our original data, whereas on the right we have the phone information, and we did this without interrupting any current data or requiring any changes to our collection. So why is this so important? I think we've already gotten the point here, but let's consider applications where requirements are evolving rapidly, such as applications that incorporate real-time data. In those cases, it's going to become crucial to move quickly without being constrained by a rigid schema and possibly having to take your application offline to remodel your database. Alrighty, do we have any questions? Hey, I joined a bit late when creating our Atlas account. We're picking the free version. Yes, you are going to pick the free version. Make sure that you take advantage of the offers that MongoDB has today for Global Hack Week participants. All right. So let's talk about data modeling in MongoDB. We talked about the flexible schema design, but you're probably wondering exactly how to model a schema for your application. So that's one of the cool aspects of MongoDB's platform. It really depends on what it is that you're wanting to build. Since document databases are capable of expressing data relationships in more nuanced ways than relational databases are, the skies are the limit here. So that means there are various considerations when developing your schema design, and we're going to jump into some of those considerations now. Before you do jump into your schema design, you're just going to ask yourself a couple of questions here, like the ones that we have on screen are going to help inform how it is that you design your database at a later point in time. So is your application read or write heavy? This is going to influence whether you want to optimize for query performance or for write efficiency. And by write, we mean just adding things to the database or retrieving things from the database. Second, we should understand exactly what data is frequently accessed together. As I mentioned before, if the data is being accessed together, it should live together. So keep in mind that general concept. Also keep in mind that MongoDB allows us to embed related data into a single document, which can significantly reduce the number of queries you need in order to access that information. So we're going to get into that a little bit later. Third, we need to think about our performance requirements. So this will influence various decisions about indexing or whether to embed or reference related data. We're going to go into indexing a little bit in towards the latter half of the presentation as well. And then finally, you need to consider scalability. I know a lot of you aren't necessarily thinking about scalability if you're just building projects for hackathons or during Global Hack Week, but later down the road, you may want to come back to that project and maybe expand it because you loved the idea and it just stuck with you. Well, MongoDB gives you the ability to do that at a later point in time, but you're also going to need to consider how your data will grow and how whichever schema design you choose will actually accommodate that growth. So really understanding your end goal prior to modeling your data will help you unlock a lot of the MongoDB benefits, especially since proper schema design is one of the most critical aspects of deploying a scalable, fast, and easy to use database. So while it may be tempting to just go in and just start designing, you're going to lose out on some of the important MongoDB features if you don't have this stuff in mind beforehand. So let's quickly go over the difference between the way you would design a relational schema and the way that you would design a MongoDB schema. So I know we've seen a lot of differences already between relational ways of doing things and the MongoDB document way of doing things. So just bear with me while, oh, sorry about that. So I skipped so many slides. So just bear with me. I don't want to be repetitive or anything like that. But here we've got, a pretty self-explanatory slide. When you're designing a relational schema, developers are going to model their schema independent of queries. So this means you're just normalizing data or the processes of splitting up your data into tables so you don't duplicate data. So in the relational example, you can see that the user data is split into separate tables and it can be joined together using foreign keys in the user ID column of the professions and cars table. So let's take a look at the MongoDB schema on the right side. So it works differently because there really isn't a formal process, algorithms, or any truly hard and fast rules that you need to know in order to structure your schema. It's important to keep in mind that when you're designing the schema, the only thing that matters is that you design one that's going to work well for your application. So you can see that instead of having our data in various documents and collections, we're just embedding the data into arrays and objects within the user object. This allows us to make a simple query to pull all of that data together for the application. So basically everything lives together and it's accessed together. And, I've said the word embedding a lot here. So we're going to quickly go over that. You got a little preview of it when I slipped and clicked a little too much there. We're going to talk about embedding versus referencing. Let me check the chat real quick. We are zooming along here. What do you think of project URL? So the MongoDB Atlas homepage should work right. Yes, it should. Definitely check that out. All right. So with MongoDB schema design, you really only have two choices with every piece of data. You can either embed your data directly or you can reference another piece of data using the $ lookup operator. So referencing is super similar to the join operator if you're coming from a SQL background. It also allows you to split up the data to make more efficient and scalable queries while you're maintaining the relationships between the data itself. So there are a handful of advantages and limitations for each choice. For embedding, some of the advantages are you could just retrieve all the relevant information in a single query. You can also avoid implementing joins in application code or by using the $ lookup function. It's possible to update related information as a single atomic operation. And keep in mind that by default, all CRUD or create create, update, and delete operations are on a single document and they're all ACID compliant. So if you need a transaction across multiple operations, you can use the transaction operator. And even though you don't want to be overly reliant on them in the application, they're definitely there as an option. So the limitations to embedding are that the large documents mean more overhead if most fields in that document aren't relevant to what your users are searching for. So you can increase query performance just by limiting the size of the documents that you're sending over for each query. There's also something to be mindful of. There's a 16 megabyte document size limit. So if you're embedding too much data inside of a single document, you could potentially hit this limit. So in practice, you want to stay below 200 kilobytes. All right. And on the other hand, we have referencing. Smaller documents are some of the advantages because you're splitting up the data. So this means you're less likely to reach that 16 megabyte per document limit that we were just talking about. Infrequently accessed information is not needed on every query, so you're not pulling in unnecessary data, and you can actually reduce the amount of duplication of data within your database. And the limitation for referencing is that in order to retrieve all the data in the reference documents, a minimum of 2 queries or $ lookups is required to retrieve all the information. So we're basically just giving the advantages and disadvantages of embedding and referencing here. Does embedding ultimately mean storing the data as a field directly? Yes, you're embedding that data into the database. So you're essentially adding a field into one of your, you're adding additional field into a document. Whereas in referencing, you're just referencing fields in different documents to kind of pull all that data together at a later point in time. So a user document is a great example because it has a one-to-one data inside of it. And if in our system, a user can only have one name, then we can model all one-to-one data as key pair values in our database. So another example is if an employee can work in one and only one department, this would be a one-to-one relationship. Whereas we have a one-to-few relationship. So let's say for each user, we need to store several addresses. Even if someone moves a ton, it's unlikely that they're going to have more than a couple of addresses. So for these relationships, these are categorized as one to few. For one to few, embedding is preferred. So obviously, we're just going to add all of that data directly into the document at hand. So for one to many, the example, let's say you're building a product page for an e-commerce website. In the system, we're saving information about all the many parts that make up each product for for repair services. So within the schema, you could be saving thousands of subparts. We don't need to have all that data for the parts in every single request. So with this, you're just going to use referencing. This will just be a waste of a ton of resources if you did it otherwise. Here, we could have a products collection with data about each product in our e-commerce store. And in order to keep our parts data linked, we can keep an array of objects ID, like link to a document that has information about that part. So the parts can be saved in the same collection or in a separate collection if needed. So as you can see here, there are two different documents and they reference one another. Next, we have many to many. So for the last schema design pattern that we're going to cover today, let's pretend that we're building a task application like Todoist. In our app, a user will have many tasks and a task may have many users assigned to it. So in order to keep the relations between those users and tasks, we're going to need to have references from one user to many tasks and references from one task to many users. So for the example on this side, you're going to see that each user has a subarray of linked tasks, and each task has a subarray of owners for each item in our task application. As you can see, there are a ton of different ways to express your schema design, but there are especially ways beyond just like normalizing the data like you normally would in a relational database. So keep in mind too that this is just the beginning of modeling with MongoDB. If you want to dive deeper into this, there are going to be a ton of resources, and we have the challenges to also like kind of like get a deeper dive into the things that we're doing in terms of like really basic MongoDB concepts. So definitely check that out. But for now, let's switch gears and chat a bit about the aggregation pipeline in MongoDB. Before we do that, let's take a look at the questions. Is the one-to-many slide depicting referencing? Let's jump back. So we got one to few, one to many. So here we are referencing the parts that are involved in a certain repair, right? And then these parts, as you can see in the parts field, you're going to have the object ID AAA. So that's referencing that part that is represented in a different document. Hope that answers your question. Let's jump back. All right. Aggregation. So sometimes you want to do more than your basic create, read, update, and delete functions, or CRUD. So you might want to run calculations, or you might want to analyze and transform your data. These would be extremely complex queries in a SQL database. So here, for MongoDB, the aggregation framework is going to start coming into play. It refers to a specific flow of operations, and it's going to process your data, transform it, and then return the results. So in a pipeline, there are a couple of different operations that are going to be informed by the previous step. So if you're implementing a pipeline, we're just going to break down queries into easier stages. And then each stage uses namesake operators to complete transformations so we can achieve our goal. So the cool thing here is that there isn't a limit to the number of stages you can use in an aggregation pipeline, but the order of the stages is going to matter. And there are just ways to optimize that. We're going to help you kind of like look at that in the next slide. So before I show you some more cool advanced aggregation pipelines, let's just take a step back, really basic stuff, and look at CRUD functionality within MongoDB. All right, so let's review syntax for a query in MongoDB. We'll always use a driver library to connect MongoDB and a query base. So this way we write code in our language of choice and send and receive objects directly into our program. As you can see, we have the DB keyword, then we have the column name, then we have the operator command, then we have the query filter, the option settings, and here we have everything put together. Okay. So now that we've kind of taken a look at how that sort of works itself out, let's look at the create and how to insert data into your database. So I'm going to show you how the MongoDB shell syntax interacts with these slides. If you're not familiar with MongoDB shell, it's just a CLI experience that you can use to work with your database. I know someone in chat asked about it earlier, but if you're not into command line, you can also use libraries for any of the major programming languages. So it supports things like C, Java, Node.js, Go, and Python. So you can easily just work with your data if you have a favorite programming language. So let's take a look at one way to insert data. So here you're inside the current database. It's going to be in the collection named authors. You're going to insert one document, and you could also use the insert many command if you want to insert it, but like here we're just using the insert one. Next, we're passing a new document to this method. So in this case, it's a document for the author Jane Austen. And then the document also includes her name and an array of IDs for the books she's written, and also an array of her aliases. So that's the create function. Let's talk about read. So this is how you would retrieve data from the database. The syntax will feel pretty similar to the command we just looked at. So here we're in the current database. You have it's named authors. You're going to use the find function. You could also use find many, but for this one, it's going to retrieve the first document that comes up, and then we pass a query to the find method. In this case, we're just querying for documents where the name is also set to Jane Austen. Someone's asking if we're going to be doing info session or if this is going to be mostly a walkthrough. So for right now, there's going to be a walkthrough. There is going to be a chance for you to go back and complete a lab for this if you'd like to, retrieve a certificate, a skill badge from MongoDB. This is just us kind of walking you through it. And then later on, we're going to get into vector search. You can also do a lab for that one as well. So, I'll provide some of those resources at a later point in time. Alrighty, so now that we kind of know about read, let's talk about update. So this is the first line. It's going to feel very familiar. Once again, we're in the current database. It's called authors. We're going to update one of our entries there. So if you want, you could also do something that allows you to update many documents. But for now, we're just going to use this one to fix a typo. So as you can see here, the first one is going to be the filter. So we're filtering for documents that have the name Jane Austen. Then we're going to use the $set command to set the name from Jane Austen with an I to Jane Austen with an E. So this way we're just updating the first document that has the misspelling in it and then updating it to the correct spelling. All right. Finally, let's talk about delete again. So this is very similar syntax. Once again, you're going to be in the current database. It's going to be called authors, the collection that is, and then you're going to delete one document. You can also delete many documents. As I mentioned before, a lot of these commands have different iterations of them. So the delete one has one required parameter, and that's the filter. So now what we're doing is we're looking for any documents that have Jane Austen misspelled. And we're going to delete one of those documents, the first one that comes up in the search. So now that we have a grasp of that, those are the basic CRUD operations that you could use with MongoDB. We're going to start, let's go back and talk about the aggregation framework and the aggregation pipeline that I had referenced earlier. All right, so we have multi-stage aggregation pipelines, and an aggregation pipeline consists of one or more stages that processes documents. As I mentioned before, it's just different queries in different stages that will then transform your data and then return the results to you. So some people like to compare the aggregation pipeline to like a Linux pipe, if you're familiar with that, where the output of one of the tools becomes the output of another. So some of the things that are cool about aggregation pipelines is you can create multi-stage pipelines on a collection that do things like filter the documents by matching on the criteria you designate, then joins the documents with documents from another collection using $lookup. And you can do joins in MongoDB, and then you can have the documents get grouped together. And then you could run a calculation like an average, and then you can sort the results. And basically, this would be a pretty complex SQL query if you had to design it all at the same time. But here with MongoDB, you can have those queries broken up into smaller steps. And basically, that is what we refer to as a multi-stage aggregation pipeline. So to run an aggregation pipeline, you're going to build an array with all the steps, and we call those stages of the pipeline. And then you're going to run it using the aggregate method. You're going to do this using your programming language of choice, or you could use the command line, and then you'll be sending the pipeline to the server to be executed. So to run an aggregation pipeline, you're going to build an array with all the steps, and we call those stages of the pipeline, as I mentioned before. And this is just an example of everything that we referred to in the previous slide, just kind of in action. You're going to see that this is the type of command that you would send to the server for execution. And yeah, it's pretty similar to the rest of the syntax that we've been looking at previously. So there are simple types of pipelines that we're going to kind of get into in the next couple of slides. So the $match is $sign match is going to be a filter stage that lets you lets documents pass into the next stage if they match certain conditions. So like we were doing before, like find documents that had the name Jane Austen, and then it brings back the name Jane Austen. So here documents are going to be searched for by pages that have by documents that have at least 100 pages. So you might be thinking you don't really need to use the aggregation pipeline if that's all you're doing. But as I mentioned before, you can use this as a series of commands that become more complex as the pipeline kind of progresses. Next, you have the $sign project, and it's going to pass along the documents with specified fields to the next stage in the pipeline. So the specified fields can be existing fields from the input documents or newly computed fields. So in this example, you're going to see that we're just looking for books within a collection. We're looking inside of the books collection, and we're looking for folks that have at least a title and a cover. Next, it's going to be the $sign limit command, which is exactly what it sounds like. Basically, you're just limiting the amount of documents that you're actually bringing into your pipeline. So here, the limit is going to be 5. So those are examples of some of the things you can do within an aggregation pipeline. Next, MongoDB's, we're going to cover arrays. MongoDB's documents can also contain arrays, which is pretty different from some of the other databases, and it could feel a little bit tricky. So we're going to walk through some of the examples there as well. All right, so in the books collection, we have an array of simple types and these are just genres. So this is just an array of tags, if you will. As you can see, we have 4 different documents with different types of genres and different titles. So if you want to query for an array that contains one particular element, we're going to use the $sign match listing, the element that will be included in the array. So here we're looking for things that include epic. And here you can see it's going to only give us Dune and Lord of the Rings, which is pretty cool. So if we want to find books that have fiction and fantasy, we're just going to go ahead and use the same $sign match, and it's going to give us all of the things with fantasy and fiction inside of them. So here it's Lord of the Rings and the 4-Hour Week. Next, if you want to find books with either genre, you're going to use match, and then you're going to use the $sign in for epic and fantasy within that actual command. And as you can see here, it's going to find anything that has either fantasy or epic inside of it. And then lastly, if you wanted to just find one, so in this case, we're going to use Dune, you're going to use the $sign match to find that document again. But this place, you're just going to use the array that has exactly the genres that book fits into. So here, only Dune is going to be selected because you were very specific with the types of genres that you wanted the actual object that you were retrieving to include. And here, you're going to see the opposite side of that. If you don't provide the exact array, there's going to be nothing returned. So another way of building out your aggregation pipeline is using arrays in order to kind of specify the data that you want to grab. So that's just another good way of looking at it. And those are the different types of arrays that you can utilize. And here, we're going to start talking about indexes. I think we have a pretty understanding of MongoDB's document model and data modeling. We're going to dive into another really important feature that enhances the performance and efficiency of your queries. So that's going to be called indexes. Indexes are just data structures that store a part of a collections data set in a way that it can be easily queried. And they are really important for optimizing the performance of your queries because they just reduce the overall amount of data that MongoDB needs to go through in order to execute that query and fulfill it. So they can be used to efficiently sort results. You can enforce unique restraints, and there's just a ton of different indexes for all of your use cases. So here are the different index types. There are a variety of them. So a single field index collects and sorts data from a single field in each document. A compound index collects and sorts data from 2 or more fields in each document. So the data is going to be grouped in the first field in the index and then by each subsequent field. Multi-key indexes collect and sort data stored in arrays. And then you have the Atlas and Vector Search indexes. So these are officially like parts of the MongoDB Atlas platform, and you could use these to support text search queries on fields containing strings. And you have hash indexes supporting hash sharding, and they index hash of the value of the field. We're not going to really be going into sharding, but if you want to do a deep dive into that, you can. And then finally, you have the clustered index, which specifies the order in which clustered collections store data. So that's another thing about MongoDB is you can actually store things into clusters. So you could have clusters of databases. And this is a lot of information, but like I mentioned before, there are a ton of different resources that we can provide so that you can do a deep dive into any of these things. Just know that you can create all of these things directly from MongoDB Atlas. You could use MongoDB Compass using any driver of your choice, or you could use MongoDB Shell. So let's take a look into the chat once again, if there are any questions. People are asking about a special version of the link. So if you go into our challenges website, it's ghw.mlh.io/challenges. All righty. Let's grab one of the challenge. I'm just going to link to one of the challenges in the chat here for y'all. All right, so this is going to be the challenge that you use to go ahead and grab your free MongoDB Atlas account. And you're going to see that there are the links there as well. And I can share this tab. So this is what it's going to look like when you actually jump in there. You're going to sign up for your MongoDB Atlas account using this link. And then you're going to, use this MongoDB, use the same link as the required URL when you actually do submit the challenge itself. All right. Let's see if we have any other questions here. Sorry, I know I did a lot of talking, so I'm just trying to make sure everyone is situated correctly. GitHub Developer Student Pack. Talk about that at a later point in time. All right. All right. I'm not seeing any questions in the current part of the comments, but there are a lot of comments there. I'll try to go into it a little bit later. All right, we mentioned MongoDB Compass. So Compass is actually a graphical user interface, and it's great for if you are more of like a visual learner and want to interact with your data. It's also a great way to create the aggregation pipelines that we were talking about before. If you want to ask questions about MongoDB, once you have your Atlas account, there's going to be the MongoDB AI chatbot. So it's really helpful. You could ask any MongoDB related questions because the chatbot itself is trained on MongoDB documentation data. So if you have a question here that didn't get answered and you have a burning desire to get a response to it, check out the MongoDB AI chat in your Atlas account, and you should be able to grab a pretty quick answer from there. Next, we have the developer data platform. So like this is just all of the things that are, encompassed within MongoDB Atlas. We've gone over the document model and how it's pretty intuitive. And along with the fact that you can just accelerate the pace that you're actually building your applications. So the cool part is when you join those two facts with the reality that when you use MongoDB, you can access all of the platform capabilities through a single API. This is just going to be a complete game changer for a lot of the ways that people are currently building applications today. So you can deploy to over 110 plus cloud regions from the 3 major cloud providers. You can have continuous uptime, advanced automation, and you could do all of the things that we talked about in the chat so far. So that is it for the MongoDB developer platform. Now we're going to start talking about vector search, beginner to pro. In the chat, if y'all could just let me know, like how familiar you are with vector search, if it's something that's important to you, if it's something that you've used in the past. Would love to know about it. Yes, we have people that are excited about vector search. Yes, not at all. I love it. So here we're just going to talk about a technique called vector search, and it allows us to search using the same language that you'd usually use to describe something that you're looking for just on a day-to-day basis. So basically like, hey, database, find me all of the restaurants in the 5 Mile area that serve fried chicken, something like that. And it's like, it's nothing like having to actually put in a query using SQL or NoSQL. So it's just a way of kind of talking to your database in your natural language. So if you're starting to build any Gen AI applications, it's really important to get familiar with this technique, because it's going to be it's going to be something that you're relying on pretty extensively as you're working. Here, we're just going to cover the basics, but MongoDB does have a more in-depth learning experience that you can try out after this workshop if you want to dive deeper. Before we jump into that, we're going to spend around, I know we only have around 15 minutes. I'm going to try to get this done fairly quickly. So we're going to talk about what vector search is, how it works in MongoDB, and we're also going to spend some time talking about tuning and optimizing your vector search queries. If you've never used vector search before, definitely check it out, because it's going to be something that comes in pretty handy. So here, there is a lab, as I mentioned. I know someone was asking about whether or not you're going to be doing any type of coding. You can follow along using this lab in the short time that we have, or you can just complete it after you kind of listen to some of this, some of the information that I provide you, because it will be useful as you go through the lab itself. Will we do RAG applications project? That's going to actually happen on Monday. There's going to be another MongoDB workshop on Monday, so make sure you check that out. It's going to be everything about RAG, and you're going to also be able to get a skills badge from that as well. The link that I provided in chat is going to be the one that you see up on the screen. Make sure that you check that out, and you can get started with the lab. It's going to take you about an hour to get through it, so just a heads up, but it is one of the challenges for Global Hack Week, and it is basically going to allow you to do all of the things that I'm going to show you in just a moment. All right. So for the longest time, search experiences on websites have been powered by a technique called lexical search. So if you've heard of lexical search before, it's just like if you go into Google and then you type in a certain, like a certain type of key phrase, then you're going to get the matches for that key phrase. So the technique, it just focuses on keywords that you input, and it's just going to fetch you the results that contain the words in the search that you input. So if you say run an online bookstore and you use lexical search to power the search engine on your website, if a user searches for Greek philosophy, they're going to see results like this, because each of these results contains the word Greek philosophy. Now, this is a great way to run your search engine, but what if you can't remember the exact title of a book, or if you can't remember the correct spelling of an author, or maybe you just remember the color of the book cover, or like a line in the book that was said? So now is when we're going to start kind of diving into why vector search is such a useful technique for folks that want to optimize the search experience of their application. So vector search retrieves results based on the intent or the meaning of the query rather than the keywords. So here, the same query that we remember before, Greek philosophy, what if you updated that website's search experience to use vector search? Even if it's the same thing, you're gonna get results that don't necessarily have the words Greek philosophy inside of them, but maybe have the word Greek philosophy within like the genre that they're logged in the database. So it's just going to be very much more aligned with the actual theme of the search query itself. You could also search using phrases that describe a book, as I mentioned before. Like, for example, we're going to run fantasy novel about a boy in a school of magic, in case you forgot Harry Potter. So hopefully you'll see that, it does return some Harry Potter entries just based off of that query. And then say you read the first Harry Potter book and you just want to read the next ones in the series, or say you want to check out more books that are similar in theme, you can even search based on the cover image. So here, for the example, we're uploading the Harry Potter first book cover and then retrieving results based on the way that cover looks. So it's supporting multimodal searches, which is really useful. So just to recap, Lexical and vector search. Lexical search focuses on retrieving results based on exact keyword matches, whereas the vector search retrieves based on the semantic similarity, or the similarity in the meaning or the intent of what the person is actually querying. So here you'd use lexical search when you're confident that your users are going to be searching for exactly the things that they want and need. Whereas if you're expecting like things to be a little bit more ambiguous, or what, like queries to not exactly match up to the things in your database, you're going to use vector search. Lexical search is also typically your first pass at building a search experience. But if you want to have a more holistic search experience that goes beyond just like looking at text, but can also support image, audio, and video, and and some other things, then you'd go with vector search. So we've talked about vector search, but we haven't really talked about what the word vector means. And we're going to kind of dive into that now. So let's say you're just walking around Home Depot and you see items that are just stored and located based on the aisle number and the bin number. So you can represent the location of the items as an array of aisle and bin. And that's essentially what a vector is. Just think about it as coordinates on a map. So for like, basically, you could just use vectors as an array of numbers to represent any particular piece of information, but this is the example we're using for today. So for an item in Home Depot, a two-dimensional vector might suffice, but in software applications, when you're dealing with large amounts of text, images, or data, then you're going to have to kind of go into a more like 3D pattern. So two-dimensional vectors won't suffice in that setting, and you're going to have to find ways to capture distinguishing features of the types of information that you have. First thing we're talking about is embeddings. So now that you've got an idea of what a vector search is, let's see what makes searching based on meaning or modalities other than text even possible. So that's where embeddings comes in. And embeddings are basically a numeric or multi-dimensional representation of a piece of information. So this information can be anything from text, images, audio, or video. What's special about this array of numbers or vectors is that they capture semantic qualities of data, essentially characteristics of data that capture the meaning or the essence of it. So this way, if you were to put a plot, if you were to plot your data in this higher dimensional space, as we mentioned, like a more 3D space, semantically similar data or data with similar meanings ends up becoming closer to each other. So as you can see, dog and cat are further away from one another than apple or orange. And we're going to talk about how you can utilize embeddings inside of your vector search functionalities in a moment. The next question is, how do you go from a piece of text or an image or audio to an array of numbers? So this is done by specialized machine learning models that have been trained to convert a piece of information to these numerical encodings. So these are specialized models that you can add to your own database or to your own documents within the database. And in the link that I linked earlier, you're going to be going through experimentation with multimodal embedding, and you could take both images and text and just like input them and then map them to the same vector space. So that's basically going to walk you through that entire process. And if you want to do a deeper dive into embeddings, you can just go ahead and search this link here. I'm going to drop it in chat for everyone as well. So these are the different types of embeddings that you can use. So based on what type of database you're building or what kind of search function you're trying to support for your end users or for the people using your application, you can search for different embedding models, and all you do is you simply reference the embedding model inside of the search query. And I'm going to kind of get into that in a little point. I'm skipping ahead a little bit, but I know someone asked, is it like an LLM? And yes, basically, we're just kind of extricating that work from you to actually allowing you to utilize existing like machine learning embeddings that will make development a lot more quick for you. So to perform vector search on your data, the first thing you need to do is just generate the embeddings for the things you want to search on. You could use the link as I mentioned before. And here, we're just going to be searching for books. So in our books document that looks like this, we have several options. We can search based on title, synopsis, or with vector search. Even the cover image of the book is now something that you can use to find an embedding model for. And you just need to find the embedding model that embeds images itself. So adding embeddings to data in MongoDB is pretty easy. As I mentioned before, you're just going to add the additional embedding field into your existing documents. So it's as simple as that. As you can see here on the right side, the original document had just the thing, like the title, the cover, the year, the pages, and the synopsis. And then the next one, once you've added the embedding, has the embedding arrays, locations, and coordinates that add that piece of data into a vector. So as you can see, it's like, you're just basically classifying your data based on the embedding that you choose. And it's pretty simple. If you think about it, you're just adding the arrays directly to the data. And if you're following along at home, or if you want to do the lab at home, you'll be able to kind of get hands-on experience with this as well. How does Oracle database, we had a question here. How does Oracle database compare to MongoDB regarding vector and embedding performance? I don't really have a definite answer for you. I would say that they are two pretty different products. Here, MongoDB Atlas is just providing you with a single platform that you can use to not only build out your database, but if you wanted to at a later point in time, add vector search to it. So hope that answers at least a little bit of your question. Right now, what we're going to do is we're going to recap what we've learned so far. And the first thing is that we've learned that embeddings are an array of numbers that capture semantic qualities of data. Embeddings are generated by specialized ML models that you can then add to your existing data. And then embeddings can be added in place into existing MongoDB documents. So let's jump into vector search. There are going to be a couple of slides here with some animations. Now that you know what embeddings are and how to generate them, you can actually fit them into a vector search, and it's going to look a little bit like this. So basically, given any user query, in order to retrieve the results using vector search, you just generate an embedding for the query, and then you'd use the same embedding model that you use to embed the rest of your data. And then you're just going to retrieve the items that are closest to that thing that you're searching for. So without going too deeply into it, we're just going to talk about how vector search works in MongoDB. So here they use an algorithm called hierarchical navigable small worlds, or HNSW. And this is what it looks like when the data is layered. And this is what, this is really the essence of vector search. So the way that it works is each layer, you have an entry point, and then as you move further within that entry point, more and more data sort of gets filtered out. And then at the end of it, you're left with data that is closest in proximity to the query that you have. So at the higher layers, it's just like really coarse. And then at the lower layers, you just narrow down to the actual thing that you're looking for. And if you want to do a deep dive into hierarchical navigable small worlds, just go ahead and check out the link there. It's definitely something useful if you want to learn more about this topic. It's, I think, something that's pretty interesting. So as you can see, the goal of vector search is to retrieve documents based on their proximity to the query that you have. So bear in mind that each query that you put into a vector search is also going to have the same embedding as you have your on the actual documents that you're searching. So what the vector search does is it calculates the distance between your query and between the items in the database. And in MongoDB, you have three options. So the first one's going to be Euclidean distance. And then what that does, it just measures the absolute or straight line distance between two vectors. Then you're going to have the dot product, and that multiplies two or more vectors to measure alignment between them. Then finally, you're going to have the cosine similarity, which is basically just measuring the angle, or the cosine here, between the two items that you have. So here the cosine similarity just helps, since it measures the angle between the vectors, which is pretty small. So the smaller, the better. Okay, so let's recap that. And sorry, I'm rushing. I know we're kind of limited on time here. We might go a little bit over if y'all have any other questions. But so far, we've learned vector search retrieves documents closest to the query embedding in vector space. Then it also uses the same embedding model to embed the data you want to search on. It uses distance in vector space to calculate using mathematical functions. And then cosine similarity works well with most embedding models. So vector search in MongoDB. Now that you understand how vector search works, like let's take a look at these 3 additional steps that you can do to generate. And so basically you've learned already how to generate embeddings. Then you need to create a vector search index. And then finally, you need to send a vector search query. So these are all of the things that you need to do in order to vector search in MongoDB. It's going to come in really handy if you're actually doing that lab that we mentioned earlier. The next thing you need to do is perform a vector search in MongoDB. Is create a vector search index to efficiently query your vector data. I think we talked about this a little bit earlier, but the index specifies the path to the embedding field in your documents, the number of dimensions in your embedding vector, and it also depends on the embedding model you use to generate the embeddings themselves. So as you can see here, we have a path to embedding. It's a vector type, and then it gives you some additional information about the embedding itself. When you actually implement that in a search, vector search is it's going to be part of MongoDB's aggregation framework. So aggregation pipelines are just a series of these like data processing steps. This is how you would perform this. It always needs to be the first stage in the pipeline and can be followed by other stages to further process the vector search results. So here's an example of the vector query. As you can see here, this is the query vector on the on the third line of this nested JSON object, and then you have the score, which is what you're searching for and like the proximity to it. So that's pretty interesting. I think this is just how it kind of works under the hood. And if you're curious to see how it kind of coexists with the rest of your data, you can effectively use MongoDB Atlas Vector Search to provide an integrated platform for your operational vector data. You could also query it and get it unified by MongoDB Query API. So there's just a ton of different things that you could do along those lines. Since all of that resides in the same collection, your data is just automatically synchronized with vector indexes, and then you can create anything that you need on the collection itself. So finally, you can also have search nodes that can scale your vector search and all of your workloads independent of what else you have going on in your application. So to recap, we perform vector search. So you know what you need to generate embeddings, create a vector search and search index, and then send a query. You also know the number of dimensions in a vector search index. It depends on the embedding model you're using. And vector search should always be the first stage in a vector search aggregation pipeline. All right. We're running out of time here. We were going to go into some pre-filtering, but I think what we're going to do now is we're just going to kind of skip over pre-filtering, and I'm just going to learn to teach y'all about the MongoDB link, the MongoDB AI Learning Hub. This is going to be something that y'all could all do. Check out the link on the screen itself. Basically, what it's going to bring you to is a lot of different learning resources that you can use in order to kind of expand your knowledge about vector search, MongoDB in general, and any of the other machine learning concepts that we sort of covered in terms of embeddings and in terms of the way vector search actually works under the hood. Is embedding subject to injections? No, it kind of utilizes the same type of data governance that any type of MongoDB any type of MongoDB database has. So it is, I would say, it would have the same type of exploitable things as any other database. It would just really depend on the way that you're building your database personally and how you have your actual application coded. All right. Isn't it something similar to how there's a hidden layer in the neural network? Honestly, I think we could just simplify this even further. We're sort of just eliminating the need for you to do any actual ML work yourself. And you could just utilize vector search out of the box by basically choosing an ML generated embedding to add to your documents. So that way you don't have to do any of the machine learning stuff yourself. The embeddings have already done that for you, and they've already plotted the data, and then it will intuitively plot any queries that you have based on the embedding that you've actually input into your database. All right. I know that this is recorded on YouTube, so is it possible to get access to this PowerPoint? Yeah. I mean, I could send a PDF and I could drop it into the Discord channel, and y'all could just basically take a look at all of the slides there, and you'll get access to the links as well, and you could just refer back to the information if it interests you. Awesome. Any other questions and answers? I know we're a little bit over time. It was a lot of information to get through, so I apologize for rushing. But it looks like everything is wrapping up here. If you want to talk about filtering, you know, I'll have the slides up that we missed that we weren't able to cover due to time constraints. But outside of that, I really hope everyone here had a great time. Coming up next is going to be the Figma to Code workshop. So make sure you keep it locked in because we're just going to be jumping right into that right after this. It's going to be me again. But I really hope everyone had a great time. MongoDB has a ton of challenges for Global Hack Week that are going to be kicking off as well. And you could just check them out on the challenges page, as I mentioned. And make sure that you do grab your free MongoDB Atlas, account, because it's going to help you to kind of get through all of those challenges and also utilize all of this information that I just gave you hands-on. Alrighty. Okay, folks. So that's going to be it for today. I will see you at the next workshop. Have a good one, y'all.